Hey Chemistry, Mrs. KJ here, going over 2.10, Review Aspects of the Atom. Review concepts presented in the lessons ions and isotopes and average atomic mass. If an atom gains one or more electrons, it becomes a negatively charged ion or anion, a negative ion. If an atom loses one or more electrons, it becomes a positively charged ion or cation because now there are more protons than electrons. Atoms of an element that vary in their number of neutrons are isotopes. Each isotope has a different atomic mass, and each occurs in nature in a different abundance. Understanding these facts makes it possible to calculate the average atomic mass of a sample of an element. And you can get the study guide. And let's review. Key concepts in ions. Atoms that carry a positive or negative charge are called ions. Atoms that lose electrons become positively charged ions or cations. Atoms that gain electrons. So now I have more negative electrons than I have positive protons. These atoms are negatively charged ions called anions, a negative ion. Sometimes a group of atoms may work together as one polyatomic ion. So it's like a pre-made ion. Ions can be cations formed when atoms lose electrons, so they are more positive. Ions can be anions when formed when atoms gain electrons. So it's more negative. So I am a negative ion, anion. Key concepts in isotopes and average atomic mass. Isotopes of an element have the same number of protons but a different number of neutrons. The isotopes of an element have the same atomic number because it has the same amount of protons, but different mass numbers because there are more neutrons. Isotopes in nature occur in certain percent abundances. So in other words, if you have two isotopes, it's not 50% of each. It might be 99% of one and 1% of the other. The mass of an atom is measured in atomic mass units, or AMUs. 1 AMU is equal to 1/12 the mass of a carbon-12 atom. It is possible to determine the average atomic mass of an element if you know the atomic mass in AMU of each isotope and the percent abundance of each isotope. Percent times mass plus percent times mass plus percent times mass. All right. Atomic variations include isotopes with varying numbers of neutrons. Atomic variations include what of which anions is a type. So ions can be anions or cations. Ions with varying numbers of electrons, represented by symbols such as Cl- to show that it has a -1 charge or one more electron than protons. And ions may form polyatomic ions, such as PO4-3. So it's a pre-made ion, PO4, and it has a -3 charge. All right, so we are going to do the problem sets. If you, thought maybe they'd give us some extra websites, but they didn't this time. All right, so let's check out problem set 14. All right, problem set 14, ions. When an atom gains or loses one or more electrons, and as a result becomes electrically charged, the resulting particle is called an ion. Neutral atoms have equal numbers of electrons and protons, so we assume that that's how it starts out. An atom becomes an ion when it acquires an electric charge by gaining or losing one or more electrons. The charge on an ion can be determined by calculating the algebraic sum, or in other words, just adding the protons and electrons, assigning +1 to each proton and -1 to each electron. The resultant charge is written as a superscript or an exponent to the right of the chemical symbol. Objectives: define the term ion, write symbols for ions, determine the charges on ions from the numbers of subatomic particles in them. In other words, figure out how many protons and electrons, put them together. Remember, ions. When indicating the charge in the superscript or exponent, write the number first, then the type of charge. Honestly, it can be either. You can write 2+ or +2. It's the same thing. For charges of +1 and -1, only the sign is needed as a superscript. So it's just Na+ or F-. If you write Na +1 or F-1, it's fine. I'm not going to mark it wrong. Many ions are made up of more than one atom. For example, SO4 minus 2 and OH minus 1 are both ions that contain more than one atom. These ions generally act as a single unit in chemical reactions. So this negative group, this polyatomic ion, is going to find a positive ion to hook up with. Subscripts in chemical formulas indicate the number of atoms. Okay, so subscripts meaning the tiny number like this, the 4 in SO4. So subscripts in chemical formulas indicate the number of atoms of each element in one molecule or formula unit of the substance. So again, that 4 means that there are 4 oxygens. Determine the number of electrons in an ion. When magnesium chloride, MgCl2, dissolves in water, it separates into magnesium plus 2 ions and chlorine minus 1 ions. How many electrons are in each magnesium plus 2 ion, and how many electrons are in each chlorine minus 1 ion? Determine the number of protons in neutral atoms of magnesium and chlorine from the atomic numbers listed in the periodic table at the back of the book, or the one that I told you to print off. In a neutral atom, the number of protons will equal the number of electrons. Magnesium's atomic number is 12, and chlorine's atomic number is 17. Therefore, a neutral atom of magnesium has 12 protons and 12 electrons. And a neutral atom of chlorine has 17 protons and 17 electrons. All right, so let's look. Magnesium has a plus 2 charge. Am I going to have more protons or more electrons? I'm going to have more protons, right? How many more? Well, 2 more. Can I change the number of protons? No, never. Okay, so I have to change the electrons. So I have to have 12 protons. So 12 minus what equals 2? 12 minus 10 equals 2. And that is what they did down here. Now, they did it the opposite way. They used the algebra to say, okay, E minus 2 equals 10. Honestly, I think that it's easier to just think of it the way I explained it. Go ahead, though, and hit pause, read through this. If this makes more sense to you, then do it this way. That's why I'm showing it to you 2 different ways. It just depends on what makes more sense for you. All right, so let's look at chlorine. So we said that chlorine normally, when neutral, has 17 protons and 17 electrons. Okay, now the charge is minus 1. So what do I have more of? Do I have more protons or more electrons? I can never change my number of protons. So I have to change my number of electrons. And when I'm done with this, it has to equal minus 1. So 17 minus what equals negative 1? 17 minus 18. So I have 1 more negative electron, which gives me a charge of minus 1. Again, if you prefer doing it this way, that is fine. Hit the pause button, read it through. I don't care which way you do it, as long as you can do it. And if it's still confusing, that's okay too. Come see me. Let me do a couple practice ones with you. All right, writing symbols for ions. Tip, remember that neutrons have no electric charge, so they do not contribute to the overall charge of an ion. Write the chemical symbol for these ions. Okay, so we have ion number 1 and ion number 2. So identify the number of protons and electrons in each ion. So this one has 8 protons, and if we add it up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So 8 protons, 10 electrons. What is my charge? 8 minus 10 equals negative 2. And so it would be oxygen, negative 2. Now, if you're thinking, wait a minute, how did you know that was oxygen? Well, I knew it had 8 protons. Anytime I have 8 protons, look on my periodic table, number 8 is oxygen. All right, so let's look at this one. Ion 2 has 13 protons and 10 electrons. So what is the charge? 13 minus 10 gives me a positive 3 charge. And what element is it? Well, 13 protons, atomic number is 13. Look on the periodic table. That means I have aluminum plus 3, or aluminum 3+. All right, write a definition for ion in your own words and explain how negative and positive ions form from neutral atoms? Okay, so hit pause, get your answer. An ion is an atom with a charge. If it's positive, it's a cation. If it's negative, it's an anion. And how do you get a negative ion? Well, to get a negative ion, you need more electrons than you have protons. So did I gain or lose electrons? I gained them. To get positive, what do I need more of? More protons or more electrons? I need more protons. Can I gain protons? No. So since I can't gain protons, but I need to have more protons than electrons, I have to what with the electrons? I have to lose them, right? So if I want to have a positive charge, I need to start out with equal amounts. So I would start out with 10 protons and 10 electrons. But now I want to have a positive 3 charge. I cannot change my number of protons. So how many electrons do I need to have to figure this out? I need to have 7 electrons, which means I lost electrons. I went from 10 to 7. I lost electrons. I'm more positive. Woohoo! How many electrons and protons are in an F plus ion? Hint, use the periodic table. So go ahead and hit pause, get your answer. So let's look at fluorine. The atomic number is 9. The mass number is about 19. So how many protons do I have? 9, which means I'm starting out with 9 protons and 9 electrons. And I want an F minus ion. All right, so I start out with 9 protons minus 9 electrons gives me a charge of 0. And this time I want a charge of -1. I cannot change my protons. So how many electrons do I have to have? 10. How many electrons and protons are in a barium ion? All right, so we have to find barium on our periodic table. And it's right down here. So how many protons and electrons does it start with? It starts out with 56 of both. All right, so I start out with 56 protons minus my 56 electrons, and I start out neutral. All right, and now I want to end up with a positive 2 charge, so plus 2. So what's my final answer? 56 protons, because I can't change them, 54 electrons. All right, let's go ahead to the next part. Problem set 15, isotopes and atomic mass. Objective, understand the mathematical relationships between atomic mass of isotopes, relative abundance of isotopes, and the average atomic mass of an element. Atoms of an element with different numbers of neutrons are isotopes of that element. If you examine the average atomic masses of most elements in the periodic table, you will see that most of them are not whole numbers or close to whole numbers. This is because the average atomic mass of an element is not the mass of an individual atom of that element. Instead, it's the average mass in grams of 1 mole of a respective sample of an element. A mole is amount, like how a dozen means 12. A mole means we had 6.022 times 10 to the 23rd atoms. The average atomic mass of an element listed in the periodic table is the average of all the isotopes of the element weighted for relative abundance. Isotopes of an element are atoms of that element with different numbers of neutrons. Isotopes of an element have the same chemical properties but different atomic masses. Sometimes they can have tiny bit differences in properties, but overall it's the same. All right, and let's start the first example in our next video.